Assalamualaikum and hello everyone. So, today my group want to present our assessment tree for the subject codes MAT183. Team members in our group are Ahmad Solehin bin Asmadi, Muhammad Adik Fikri bin Abbas and Muhammad Ashraf bin Mohtar Sani. The title of selected topic from us is Application of Differentiation. Before that, let me talk about introduction first. So, what is differentiation? And why use differentiation?
What is differentiation or derivative? Differentiation is a process of finding a function that outputs the rate of change of one variable with respect to another variable. We need differentiation when the rate of change is not constant. Why use differentiation or derivative? Differentiation can help us solve many types of real-world problems. We use the derivative to determine the maximum and minimum values of particular functions such as cost, strength, amount of material used in a building, profit, loss, and many. It also can use to solve the related rates problem. Involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time. Derivatives are made in many engineering and science problems, especially when modeling the behavior of moving objects. Our discussion begins with some general application which we can then apply to specific problems.
Next is about the problem statement for the application of differentiation. So, our group choose the related rate problem for our assessment tree about the application for differentiation. So, the problem is Ashraf walks at a rate of 3.5 meter per second away from a lamp post one night as shown in the diagram on the right. The heights of Ashraf and the lamp post are 1.2 meter and 4 meter respectively. Find the rate of change of Ashraf's shadow and the moving tip of the shadow. Before that, we look the key concept before solve the problems. So the key concept is to solve a related rate problem. First, draw a picture that illustrates the relationship between the two or more related quantities that are changing with respect to time. In terms of the quantities, state the information given and the rate to be found. Find an equation relating the quantities and use differentiation, applying the chain rule as necessary to find an equation that relates the rates. And then be sure not to substitute a variable quantity for one of the variables until after finding an equation relating the rates. So let's do the solution. So first we draw the triangle here from the information from the diagram, and this is height of lamb and this is height of the Ashraf. Next, the length lamb to Ashraf will be represented as x, and the shadow length will be represented as y. and L is the sum of the x and y. Look at the problem. Part A is asked for dy dt, that's the rate at which the length of the shadow is changing, so that's how fast y is changing. And part B, at what rate is the tip of his shadow moving? When the tip of shadow move, in this case, that's going to be equal to the rate at which L is changing. So, part B is already looking for dl dt. So, how we calculate dy dt and dl dt? And how we want to get the equation? Before that, we also know that here information, the positive 3.5 meter per second is the dx dt, because Ashraf, he walks away from the lamp. So we can draw two triangles. This the first triangle, and the second triangle is this. So we can use the concept of trigonometric for the both triangle. For the first triangle, it will gonna be tangent theta equal to 4 over x plus y. And the second triangle, we can do tangent theta equal to 1.2 over y. So we can make the equation 4 over x plus y equal to 1.2 over y. So now we can do the solution. So we want to make the equation to be y in terms of x. So y is times with 4 and x plus y times with 1.2. And it's gonna be this. And 1.2 is times with x and y. So, and then this 1.2 y can be to at right, at left, and 4y subtract with 1.2 y equal to 1.2x, and this can be 14 over 5y equal to 1.2x, and last y equal to 3 over 7x. So then we can do differentiate this equation. So we differentiate, it will be dy dx equal to 3 over 7. So we can find the dy dt using the chain rule. So this is dy dt, and at here we take the dx at here. So we can find the value for the dy dx. So the dy dx is 3 over 7, and dx dt is here 7 over 2. So 3 over 7 times to 7 over 2, it will get the 3 over 2 meter per second, or 1.5 meter per second. So here is the dy dt. So next, let's we try to find the dl dt. So how to find dl dt? The solution is like same with before, like a part A, but at here it will be the L. So before that it is the x plus y, but now we use L because L is sum of x plus y, sum of xy. So we take the L here because we want to find the dl dt. So let's do the solution. So y times with 4 and L times with 1.2. So it gonna be for y equal to 6 over 5L, and then we want get the y in term of L. So I'm sorry, the L in term of y, because we want to find the DLDT. So L must be in term of L in term of y. So just change just change the position, the 6 over 5L at left and 4y at the right, and then 4 divide the 6 over 5, it will get the 10 over 3y. So L equal to 10 over 3y. So we can do differentiate this equation. So we differentiate will be the dl dy equal to 10 over 3, because this y is power of 1, and power of 1 is subtract with 1, we'll got the 0. So y 0 will be 1. So it will be the 10 over 3. So next we can do find the dl dt. So dl dt, dl and dt at here, and at here is dy. So the value for dl dy is here, and the dy dt is here. I'm sorry, dy dt is here. Okay, so dl dy is 10 over 3, and dy dt is 3 over 2. So 10 over 3 times with 3 over 2 will get the 5 meter per second. So that's how to solve the problem about the related rate problem in application of differentiation.
There are various applications of derivatives not only in mathematics and real life, but also in other fields like science, engineering, and physics. To recap what we have learned thus far, the derivative is defined as the rate of change of one quantity with respect to another. In terms of functions, the rate of change of a function is defined as dy dx equals to fx equals to y prime. It can also be defined as the varying rate of change of a function with respect to an independent variable. The derivative is primarily used when there is some varying quantity and the rate of change is not constant. The derivative is used to measure the sensitivity of one variable, which is the dependent variable, with respect to another variable called the independent variable. The process of finding the derivative is called differentiation. The inverse process is called anti-differentiation. The derivative of a function y equals to fx is the measure of the rate at which the value of y changes with respect to the change of variable x. It is known as the derivative of the function f with respect to the variable x. The concept of derivatives has been used in small and large scale. The concept of derivatives is used in many ways, such as change of temperature, rate of change of shapes and sizes of an object, or in this presentation's case, the length of a shadow relative to the light source. The application of derivatives allows for easy calculation to reach the answer. In conclusion, derivatives are constantly used in our everyday lives to help measure how much something is changing. They are used by the government in population censuses, various types of sciences, and even economics. Knowing how to use derivatives, when to use them, and how to apply them in everyday lives can be a crucial part of any profession. Therefore, learning early about the overall subject of derivatives can be highly beneficial for our livelihood.